This video is about writing equations for exponential functions with only a vertical stretch or compression. And this is also, there's no shifts up or down, and horizontal asymptote is just the x-axis. So the best way of doing this is finding what the a value is, what the b value is. The a value is the easiest to find when the horizontal asymptote is at 0. The a value is simply going to be the y-intercept, the y value at the y-intercept. So the y value there is 25. The b value is pretty easy to find too. You're going to go over to 1, then you can go over and touch the graph. You're looking for the y value when x is 1. And the y value there is 50. You should take the 50 and you should divide it by a, which is 25. So b would be 50 over 25, which is 2. So I know a and I know b. The general form for those kind of equations is y equals to a, then b raised to the x power. Since a is 25, this equation is y equals to 25, b is 2, that's raised to the x power. This equation represents this species y growth in its population over time. That's what you do. Here's another equation as application, and it deals with some species x and its population growth over time. So again, you need to find a and you need to find b. So a, in this case, it's kind of hard to tell because they're counting by 50s. So they did you a favor by giving me order pair here. The a value is 5 because that's the y coordinate of the y-intercept. So no, a is 5. So I would find b by going over to 1. And since I would go over and touch the graph, you really can't tell what that is. So luckily we have an ordered pair. The output at 1 is 15. So I will use 15 and I divide by the a value, which is 5. So b is going to be 15 over 5, which is 3. So now I have a and b. So the equation of this is still a and then b to the x. So this population of species grows at 5 times 3 to the x power. And that's it. You just find a and b from the graph that way. Let's try a few more. So here's another one. Here, if you actually want to find a and b, first of all, we got to decide whether or not this is growth or decay. And this is actually going downwards as I go to the right. As I go from left to right, my graph goes down. So this is a decay model. So to find the a value is still the y-intercept there. So you can see that that's actually at the number 2. So the a value is 2. The b value, I'm going to take the output at 1, which is 1. I'm going to divide it by my a value. So to find b, I'm going to get the output at 1, which is 1. So it's going to be 1 divided by the a value, 1/2. So the equation for that model should be y equals to 2, then 1/2 raised to the x power. And I can check it and make sure it's right. For example, if I plug in -1 into that equation, I should get an output of 4. So if I check, it should be 2 times 1/2 to the -1. And if you plug it into your calculator, you should get 4. If you check the other point, at -2, the output should be 6. If you look a little closer, actually this is 6, 7, 8. The output should be 8. So if you actually check at -2, so y equals to 2, then raised to times 1/2 raised to the -2. If you plug that into your calculator, you should get an output of 8. So it does work for all these points. So that's the equation that models that graph. Here's a new one. Here, I still need a and b. A in this case is up here. If you look closely, it's counted by 3s. So if this is 18, that's 21, that's 24, and that's 27. So a is 27. And to find the b value, you should go over the 1, find the y value there. So this is 9. So I'm taking 9 and divide it by 27. That is 1/3. So the equation for this graph would be y equals 27 times 1/3 raised to the x. Oh, yes. The equation is a b raised to the x. So since a was 27 and b was 1/3, that's the equation for that model. So a was 27 and b was 1/3. Let's do some more. Take a moment. See if you can try this one on your own. Take a look at this picture and decide whether or not you can find a, and then see if you can figure out what b is. So pause the video and see if you can find a and b. All right, if you tried it, you should have saw the a in this picture had to be 3. And this is counted by 0.5, so at 1, the output is 6. So the b value is going to be 6 divided by 3, which is 2. So that equation should be y equals to 3, then 2 raised to the x power. And that would be the equation for that graph. Or you could check it, you can plug in numbers to see if it gives you those outputs. For example, at 2, it looks to be the output of 12. And I can check. I can plug in y equals to 3 times 2 to the second. 2 to the second means 4, so 3 times 4, but that's definitely 12. So it does check out for the points. Here's a new one. This one you got to estimate a, and you can still find out b. This one is different though, because the 1 value gives you a decimal that you kind of have to guess about. So instead of using 1, our other good point, if you can't use 1 would be the ideal point to use to find out the b value. But if you can't use 1, you can use -1. That just means whatever you get for b, you have to get the reciprocal of it. So let's do this one together. Clearly a is about right here, and that looks to be 1.5. And if I go over to -1, the output at -1 is at +3. So b should be +3 divided by 1.5, and you get 2. But since we use -1 instead of regular 1, we have to get the reciprocal of this. Reciprocal. So the reciprocal of 2 is 1/2. So instead of being b is 2, b is really 1/2. So that's not really b. B is really the reciprocal of 2, which is 1/2. So that equation would be y equals to 1.5, then 1/2 raised to the x. And it makes sense for it to be 1/2, because this graph represents decay. So b could not be 2, because if b was 2, it would be representing growth. It would be a graph that is a J curve that goes up in this direction. So it makes better sense for it to be 1/2 anyway. Well, that's all I have. Good luck.